Hello friends, this is Gangadhar with another question asked in Advanced 2019 Paper 1 for a numerical value type. See, the question is a combination of circles, a little bit of coordinate geometry along with the concepts of geometry. See, in the question it is given that B is a point which is the reflection of A with respect to the line, right? And then gamma A and gamma B are two circles of radius 2 and 1 with the centers AB. Then C is be the point of intersection of direct common tangent and the line through A comma B. Then length of the line segment AC is, that's what we need to find. See, as per the given problem, first suppose here we have the line which is mentioning as some like 8x minus 6y minus 23 is equals to 0. And suppose this is the point A 2 comma 3, and then we need to locate reflection of A with respect to the line, that in the sense image of A. Suppose if this is the reflection of A, then by the property of reflection the distance from A to the line is equals to the distance from B to the line. These two distances are same by the property of reflection, right? Yeah. So I have the points here. Now what I am going to do is circles. I need to draw two circles of radius 2 and 1 with centers A comma B. With A as center we need to locate one circle. With B as center we need to locate another circle. See, if I draw a circle with A as center of radius 2, whether it touches the line or not. To check, calculate the distance from this point to the line. Distance from 2 comma 3 to the line is nothing but what? 8 into 2 minus, I am going to calculate the distance from 2 3 to the line. See where I can calculate this way. For the space I am searching, and this point is 2 comma 3. So 8 into 2 minus 6 into 3 minus 23 divided by root of 8 square plus minus 6 square. And if you calculate 8 2 is 16, and then since we are going to calculate the distance, modulus of this one is the distance. 8 2 is 16 minus 18 minus 23. 16 minus 18 is minus 2, and minus 2 minus 23 is 25. This value is 25 by 64 plus 36, 100, and that is 10. On simplification you have it is 5 by 2. 5 by 2 is nothing but 2.5. So the distance from A to the line is 5 by 2, which is 2.5. And I am going to draw a circle of radius 2. So since the distance is 2.5 and the radius of circle is 2, surely the circle never touches the line. This distance what we calculate as 5 by 2. So the circle may be like this, of radius 2, and another circle of radius 1, and the circle is like this, of radius 1. This radius is 1, this radius is 2. Now what our task is, we need to draw a direct common tangent for the two circles. First, suppose if this is the direct common tangent, and if you extend this side, the line joining A and B, the line joining A and B and this direct common tangents will meet at a point C, and then I need to calculate the length of AC, right? See, question is this one, so I am going to erase this. See, if you look, we have two circles, circle 1 and circle 2, okay? And this is the direct common tangent, and this is center A of first circle, this is center B of second circle. Line joining A and B will meet at the point C, and they ask us to calculate the distance from A to C. Suppose this line touches first circle at some point T1 and the second circle at some point T2. I need to calculate AC, right? Right. Now if you look here, if the line touches here at T1 and here at T2, and this line is surely perpendicular because it's tangent line and this is the radius line, and this is also surely perpendicular, tangent line and the radius line. And if you observe this triangle CBT2, as well as CA-T1 are similar. Since this CB-T2 as well as CA-T1 are similar, and since they are similar, okay, the ratio between the CB and CA is equals to the ratio of what? Their radii. Since these two triangles are similar, CB by CA, CB by CA is equals to, this radius is given as 1 and that radius is given as 2. 1 is to 2. Okay? And see what we have here actually, this distance from A to the line is 5 by 2. In the same way, the distance from line to B is also 5 by 2. Right? I need to calculate CA, the total triangle. Right? CA, CB by CA is equals to that 1 by 2. So CB part and then CA part we have. So this CB minus AB is nothing but this AB, the distance is 5. Here it is 5 by 2, here it is 5 by 2. The distance from A to B is 5. So this ratio is 1 by 2. So you just let the distance from C to B as some K, and then from C to A as some 2K. And the difference between these two is again some K. Since the difference is K, the difference is AB, and the value of K is equals to 5. Since this K is 5 and they ask us to calculate AC, which is nothing but K plus K, 5 plus 5, and your answer is 10. So the length of the line segment AC is 10. That is the question asked in the given problem. Right? So once again, if you look here, initially with the B is the reflection of A, I framed the reflection, and then to draw the circle, I observe the length. This length is 5 by 2 and the radius is 2. So this circle won't touch the line. So this is one circle and this is another circle. For these two circles, we need to draw a direct common tangent, and the line segment passing through AB will meet at C. Now if you observe this CB-T2 and CA-T1 are similar, then we have that CB by CA as 1 by 2. Then from this, if this length is K and this length is 2K, this is also K. This is from A to B. From here A to B is 5 by 2 plus 5 by 2, 5. So K is 5 and AC line is 10. Our answer is 10. Thank you.